Okay, let's proceed and finish these last 4 examples on graphing inequalities. So, another way we could graph this line, since it's in standard form, is using x and y intercepts. So, let me refresh your memory on that method. So, x and y intercepts are ordered pairs. They are ordered pairs on the x-axis or the y-axis. So if I'm on the x-axis, my ordered pair is always in the format of a number, comma, 0, and my y-intercept is always going to be 0, comma, a number. Now that we know half of our ordered pair, let's plug the 0 in and calculate the other variables. So on my x-intercepts, if I plug my 0 in for y, let's momentarily change it to an equal sign. So I end up over here, x plus 0 is really just x, so my x-intercept is 12. Now do the same thing for y-intercept. Plug the 0 in for x. So 0 plus 3y is 12. So that's really just 3y equals 12. Divide both sides by 3, so we get a 4. Now, I do run off my graph just a touch, so I'm just going to, since it's only 2 spots, I'm just going to extend it out too, because these are 10 by 10 grids. Now, 0, 4 is going to be right here. Now, let's pause. Am I making a solid or a dashed line? So this is just a less than sign. This is a dashed line. So I'm going to do my best to make a dashed line that's fairly straight through my points, okay? Now I need to decide, do I shade above the line or below it? So I'm going to plug in 0, 0 unless the line goes through 0, 0, and it's not. All right, so let's do our test point of 0, 0. So let's rewrite the equation but plug in 0 for x and y. So it reads 0 plus 3 times 0, is that less than 12? Well, if you think about the left, it really just says 0 plus 0. So it really is, I'm really evaluating this. Is 0 less than 12? Yeah, that's true. So that means I want to shade in wherever 0, 0 is on that side of the line. So since 0, 0 is down here, it's below the line. Since that's true, I'm coloring in this region of the graph with that point, okay? If I would have gotten a false answer, I would color in the other side. All right, now I want to show you another way. Let's say you don't want to do intercepts, okay? Let's say you want to rewrite this in slope-intercept form, because you can always do that. So if I want to do that, I have to solve for y. So I would take away x from both sides. So that would leave me 3y is less than negative x plus 12. Divide by 3, divide by 3, divide by 3. So that gives me y is less than. So negative x over 3 is the number negative 1/3 x. And then 12 plus 3 is 4. So if we go to graph that, here is that y-intercept of 4, and I would count my slope down 1 over 3, down 1 over 3, down 1, 1, 2, 3, down 1, and there I land. Okay, so if you're not comfortable with the x and y intercept approach, you can rewrite it in slope-intercept. Okay, so I'll probably do a mixture of that just to help you see that. All right, let's go on to number 5. Okay, let's graph. So I'm going to go ahead and do slope-intercept form here. Okay, if you want to jump into intercepts, that's totally fine. But I do want to show you one potential tricky piece on slope-intercept. Okay, so let's solve for y. So take away 3x from both sides. So that leaves me with negative 2y is less than or equal to negative 3x plus 6. So divide by negative 2, divide by negative 2, divide by negative 2. Okay, one potential thing. Do you remember what happens when we divide by a negative number? We have to flip the inequality symbol. So this would read y is greater than or equal to Negative 3 over negative 2 simplifies to a positive number, so positive 3/2. 6 divided by negative 2 is negative 3. Okay, so let's graph our M and our B. So negative 3. So I'm going to go up 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Oops, I went over 1, I think. Up 3 over 2. 1, 2, 3 over 2. And like I said earlier, I just like to fill the whole graph up. Since I'm not using a ruler, this will help me make my line as straight as possible. Okay, dashed or solid. So it's an or equal, so it's solid. So let's make our line go through. Now I need a test point. So 0, 0 is open. So let's plug that in. So 3 times 0 minus 2 times 0. Is that less than or equal to 6? Well, all of it is 0 on the left. So you have to decide, is 0 less than or equal to 6? Yes, 0 is smaller than 6. So here is 0, 0. So that means I'm shading on this side of the coordinate plane, this side of my line. Okay, so step 1 is to graph. And if you want to do x and y intercepts, that's fine. If you want to do slope intercept, that's fine. Check for dashed or solid, and then plug in your test point and go forward. Okay, I want you to look at 6 and 7 for a minute. These are what we call special, usually we call them special linear equations, because there's only one variable. Okay, so what I want to do is, you might remember how to graph these, okay, but you very well may not. So here's what I want to recommend for graphing one variable equations. I want to make a table of values, and for a minute, let's just turn it back into y equals 3. So if y equals 3, y is always equal to 3 no matter what x is. So I'm going to come through here and put 3 ordered pairs in where my y's are 3. It doesn't matter what x is, it never changes the value of y. Okay, now we can plot that. So 0, 3, 1, 3, oops, let me make my dots a little smaller here. 0, 3, 1, 3, and 2, 3. So can you see the horizontal line forming? Okay, before I draw a line, is it solid or dashed? This is just less than dashed. So let's go through here and make a horizontal dashed line. Okay, let's also think about, we can plug in or we can just think about this. If you want to plug in a test point of 0, 0, you can, but there's only one variable to look at. So is 0 equal to, I'm sorry, not equal, I forgot my inequality. Is 0 less than 3? Well, yeah, that's true. So I'm going to shade below. The other way to look at it is you're shading all of the values under the line. So either way you look at it, I'm shading under the line because it says y is less than 3. Okay, or you might just remember all equations in the format of y equals a number are horizontal, okay, and then you go forward. But if you don't, make yourself a table of values to graph. Okay, I want you to pause the video and try 7. I want you to make a table of values like we just talked about, but this time the equation says x is less than negative 2. So please pause and then come back and check your answer. All right, I'm making my table. The x's are 2. Doesn't matter what y is equal to. So 2, 0, 2, 1, 2, 2. So it makes a vertical line. It is solid. So I am making just kind of what looks like our typical line. And when you decide on your shading, It's vertical. So I can do one of two things. I can say, well, that is a less than sign. So all of the numbers, I want to shade all the x's that are less than -2. Well, all of the x's that are less than -2 fall on the left. Okay. You could also plug the 0 in for x and decide if that's true or false. Is 0 less than, oh shoot, I just messed this up. Okay, let's back up. I have graphed this wrong. And so I made a mistake that very likely you all made. This is a -2. I completely missed that. So these should be -2, which means my line is over here. So let's fix this here before I go any further. So I caught that when I plugged that test point in. So I'm glad I did that. Okay, let's back up. Here we go. It is vertical through -2 on the x. So as I was saying a second ago, this is true. So what I caught, actually I back up. This is false. 0 is not less than -2. So where I caught my mistake is I was starting to color in on that point. So since 0 is right here, I don't want to shade over there since that's false. I'm going to shade on this side. Okay, so if you have questions on this, please ask, because it takes a little bit to get down, but there are a lot of concepts we've studied in the past that I think you can build on. So tomorrow or the next lesson, we're actually going to add 2 lines on here, but let's just practice with one right now.